All right, guys. So again, we are continuing on with this note sheet here. Yep. Brianna, you also have one on your desk. Because I gave you that one, and I just took the first sheet from it. Now, again, with these here, when we're doing these and solving these, there's a big focus on connecting it with the general form and connecting what we have, the information we have with the general form, and finding the piece of information. So looking at this next one here, again, we want to find the equation of this parabola, the one that's given to us. And the way that we do this is by figuring out, one, which equation we're looking at, our x equals or y equals. Now, as we said yesterday, our y equals is going to open up or down. The x equals is going to open to the left or to the right. And if we look at this one here, which way does it open? It opens up. So that means we're looking at the equation 1 over 4p.
His dad is here now to pick it up. Thank you.
So we have this equation here. Now the missing terms that we need are h, k, and p. Because we still have the x and y value, or x and y, they will stay in there for the final form, but h, p, and k are the ones we need. Now again, just like the previous ones, they gave us the vertex and the focus. Now in the general form for both of these, the vertex is the point h, comma, k. The vertex is the point h, comma, k. And the focus, now again, we need to go back to the general form, the equation. And if we look at the equation, y equals, then go down to the focus, our focus is the point h, comma, k plus p. H, comma, k plus p. And just like yesterday, we're not really doing anything over the top. Because it's y equals, this is the setup for the vertex, this is the setup for the focus, and we're connecting them back to each other. And that's going to be key for all of this here. How do they connect? How do they relate? How do we plug these in? Because the vertex tells us the value of h and k. And the value for h is 4. The value of k is 2. And even if we look at the focus, the first one, it's just h, and the focus's point is just 4. It does agree that h is 4. Now what it also tells us is that k plus p is 11 over 4. K plus p is 11 over 4. Because again, for us to be able to plug this in, we need the values of h, k, and p. We need all three, because if I have all three, we can find the equation. Now this is helpful. K plus p is equal to 11/4 because we already know what the value of k is. The value of k is 2. So we can plug that in. So we're saying 2 plus p is 11 over 4. Are there any questions on any of this here? Now to solve for the value of p, we would minus 2 from both sides. Now at this point here, we can do this in the calculator. We can say 11 over 4 minus 2 is 3/4. But again, when we found the h, k, and p, as we were lining it up with the general forms, and going from there. The vertex gave us the h and k because the vertex is the point h comma k. The focus is our h comma k plus p. We're able to find p by plugging in the value of h. Questions on this here? Questions on anything we've done so far? Now at this point here, to find the equation, we're going to plug back in. Y is equal to 1 over 4p. Well, p in this case is 3/4 times x minus h. Well, h in our case is 4 plus our k value, which is plus 2. Now we do need to simplify our fraction in the front, 1 over 4 times 3/4. And again, we can plug this into a calculator. 1 over 4 times 3/4 is 1/3. Now it won't always work out that they'll simplify nicely, but we will normally have some type of fraction or a whole number. And that's it. Questions on any of this here? Any questions on anything we've done thus far? All right. What am I missing? This is missing a little bit of piece of information. And that's that equals y. So that's the one piece it's missing, yes? Everything else is the same.
Not on mine.
Yeah.
Y is equal to negative r, so that is it, but it's
Yeah, it's missing from the slide. Yeah. Now looking at this here, we're given the vertex, and this time we're given the directrix, yes? Now we still need to determine which equation we're looking at. X equals or our y equals? Y equals, because again, when we determine this, I'm going to go and look at both of these sets of given information, both of our general forms, and see what it tells me. Now the vertex isn't going to determine by itself. The vertex by itself will not tell me which one I have, because the vertex for both forms is h comma k in both equations, yes? So we look at the other piece of information. It told us the directrix. For our y equals, the directrix is y equals. For our x equals equation, the directrix is x equals. So one of them, it is y equals k minus p. The other is x equals h minus p. Yes? So when we look at this one here, it says the directrix, on your paper it's the other way, y equals negative 27 over 2. Well, only one of those two equations is set up that way. So it's telling us the equation we want for this is going to be our y equals 1 over 4p times x minus h squared plus k.
down. It's y
Yeah.
and if it goes to the left, right.
So,
Oh, never mind.
yeah. So the reason we're able to tell this specifically is the directrix is the equation y equals a number. So our directrix for this one here is y equals k minus p. So because it's y equals, we're going with that form. Does that make sense? Because again, if there are questions on this at this point, it's going to be better to address them now. Because this here, once we see how they work, how they connect, it's going to be easier going forward. Because the directrix, there's only two ways we can have the directrix equation in a parabola. either y equals a number or x equals a number. And we determine which equation based off of that. Now, the vertex is still the point h comma k. Now, our directrix in the general form was y equals k minus p. And still, just like the previous ones, for us to find our equation, we need the value of h, k, and p. We need all three. We still need h, k, and p. For finding the equation of any one of these here, we need the values of h, k, and p. Now, from the vertex, we know what the value of h is. It is 5. Because the vertex is h comma k. The vertex that is sold to us is 5, negative 1. So the value of h is 5. What is the value of k? But we still need to find the value of p. Now this here, to find the value of p, is we're looking at the directrix. So we have two equations, yes? For the problem that we're given, we're told that the directrix is the equation y equals negative 27 over 2. That's what it told us it is. In the general form, y is equal to k minus p, yes? Both of them have y, yes? So we're not focused on that. But we know that the k minus p is taking the place of what? Negative 27 over 2. Those two line up. Those two are in the same kind of location. So really what this is telling me is that k minus p is equal to what? Negative 27 over 2. When I plug in the value of k and p for this problem, we will get the value negative 27 over 2. So k minus p for this problem is negative 27 over 2. And again, just like what we did with the previous ones, even though we weren't given the focus, I'm still lining it up. I'm still matching it up the exact same way. Yes? Now we already know what the value of k is. It is. So we have negative 1 minus p is equal to negative 27 over. Now we need to solve for the value of p. Yes. Which will tell us that negative p is equal to, well, negative 27 over 2 plus 1 is negative 25 over 2. Now at this point we can divide both sides by negative 1, which negative p divided by negative 1 is just p. (25 over 2), because all we're doing is changing the sign. It's going to be 12 and 1/2, 12.5. But at this point, it's going to be easier just leave it as a fraction. So that's it for finding h, k, and p. But just like the previous problem, we still need to plug it back in. Because again, we're trying to find the equation. And to find the equation, we need the values of h, k, and p. And once we get those values, y is equal to 1 over 4 times p. Well, p is 25 over 2 times x minus h. Well, the h value is 5 squared plus k, and k is, yes, now we can plug 25 over 2 in the calculator, let it simplify it for us. Here, in this case, it's 1 over 50. It's not always going to work out that we get 1 over a number. We can have a number in the numerator other than 1. But all the ones we've had up to this point so far have been 1 over something. Inside the parentheses, we will still have x minus 5 squared. And instead of plus -1, we have -1. Questions on any of this here so far? It's still the same thing, but we're looking at different pieces of the puzzle to get to it. Questions on this here? Questions on anything we've done so far? Write an equation of a parabola with a vertex of -1, 4 and a focus of -1, 2. Now, when we're given the directrix, like the previous problem, it's a little bit easier to pick between the two equations. Because one of them, the directrix is x equals h minus p. The other, the directrix is y equals k minus p. It's kind of easier to pick out between the two. Now, with this one here, we're given the vertex and focus. So we have the vertex and focus. Now our vertex is the point h comma k. Yes? Now for us, our vertex is the point -1, 4. So we still have our h, we still have our k. And they told us the focus is the point -1, 2, yes? Which one of the two values stayed the same? The x value or the y value? The x, from the vertex to the focus, the x value, the h, is the same in both, yes? So let's look back at our original forms. So if I look at the horizontal, the bottom one, going from vertex to focus, well, I start off with h for the vertex, but the focus's point is h plus p. I'm adding that value p to it. So is that going to change the value of h? Well, yes, it's going to change it by some amount. Either it's going to increase it or decrease it, depending on the sign. Now, if we look at the other value, unless p is 0, but if we look at the other one, k to k, yes? Now, if p is 0, well, if we look at this equation, I'll write the whole thing, I minus k squared plus h, yes? So let's look at that for a second. If p was 0. If p is 0, this fraction becomes 1 over 4 times 0, yes? What is 4 times 0? What is 1 divided by 0? We can't divide by 0. It's undefined. So, can p be 0? No. So p can't be 0. So luckily, that's one case we don't have to worry about. So whenever we're looking at vertex to focus, we're trying to see which value changed, which one stayed the same. For this one here, the x value, the h value stayed the same from one to the other, yes? So from here to here, well, this one, the h value, the x, the first value is going to change, yes? If we look at this here from vertex to focus, did the first value change? No. Which one did? The y value, the k, where k is for the vertex, yes? Let's look back at the other form. From here to here, h is still h. We don't have anything added or subtracted from it, right? But if we look at k, it's going from k to k plus p, yes? Which means the two equations, or the equation we need for this is actually y equals 1 over 4p times x minus h squared plus k. Questions on this here? Now, if it had been the vertex is negative 1, 4, and the focus was 2, 4, where the y values, the second value from vertex to focus stayed the same, then we would have x equals. So when I'm looking at this, I'm looking at which value is changing. Is it the x value, the first value, or is it the y value, the second value? Because if it's the second value, the y value, we're looking at y equals. If it's the first value, the x value changes from the vertex to the focus, then it's x equals. Questions on how we determined which equation? But I'm hoping that you notice everything we've done today, picking, even right here, picking out which one we have, is still looking back at the equations in the general form. And how are they working? How is it affecting the function? Which one's changing, which one's not? And using these general forms to work these problems out, because that is what everything of this section, this part right here, is revolving around, is these general forms. Because again, our focus is h comma k plus p. Now our value of h, the vertex does tell us it is negative 1. The value of k is 4. And if I look over at the focus, focus's general form is h comma k plus p, yes? Well, the h value for the in the focus is still negative 1. It still agrees with that, yes? But it's also telling us that k plus p is 2. So again, to find the third piece of information, we need to know the value of p. Well, what is the value of k? So 4 plus p gives us 2. Yes. Because how do we go from 4 to 2? We decrease by a value of 2. So to solve that, we would subtract 4 from both sides. 4 minus 4 is 0, and 2 minus 4 is negative 2. Questions on this here? Again, questions on any of this here so far? Now, the last thing we need to do is plug it in. 1 over 4 times p. Well, p is negative 2. Parentheses, x minus h squared. Well, x minus negative 1, which is indeed going to be plus 1, because we can rewrite it out in a second. Or if you wanted to rewrite it out as x plus 1 at this point, that is perfectly fine. Plus our k value, which is 4. Because inside the parentheses, we will indeed have x plus 1 squared plus 4. Guys. Yep. So our 1 over 4 times negative 2 does become negative 1/8. And we get this here. Questions on this here? Right, so for this one here, the directrix is our y equals k minus p. Well, the value of k in our case is 4 minus -2. So we're plugging those values in. Our negative would be plus, so the directrix for this problem would be y equals 6. But hopefully you also see, if I want to find the values given an equation, I need to know 3 things. I need to know the values of h, k, and p. Because if I know those 3, we can go from one to the other, or backwards. I can go from the equation to our vertex, focus, directrix, and axis of symmetry, or I can be given a piece of information and go to the equation. We can go from one to the other. Questions on any of this here? Yes. Right. I will, and if I don't, I'm definitely going to rewrite them back up there so you have them. So I would have them down somewhere to refer back to. And the reason I say that is, one, I mean, memorizing this, if you really want to, I'm not going to stop you. But after this chapter, this doesn't mean a whole lot. So there's not a whole lot of reason to memorize it, because we'll use it now and then that's about it. And it's very easy to flip, especially the focus and directrix for these equations. It's very easy to do it. Now let's look at the next one here. Now the next one they gave us, they told us the vertex and the directrix. Well, this one has the whole thing. And the nice thing with the vertex, it's always h comma k. It's going to be up and down because the directrix comes in only one of 2 forms, either y equals k minus p or x equals h minus p. So since this is y equals, we go to the version of the equation that has that, which is our y equals 1 over 4p times x minus h squared plus k. I'm using this version of the formula because its equation of the directrix is y is equal to k minus p. It matches up to it. Right, so we need to find the value of h, k, and p. And looking at the vertex, h is indeed 8, k is 9, and p we have to do a little bit of calculations to find. But based off how this is set up, we know that k minus p is what? 73 over 8. Because our directrix y equals 73 over 8 is our directrix. And its part in our general form is our k minus p. It's taking the place of k minus p. And k in our case is, so 9 minus p is 73 over 8. Now to solve for this here, we need 2. Question? For directrix, yes. For directrix, yes. Because for directrix, we're subtracting p from it. For focus, we're going to add p to it. Now for us here, we have that negative p is equal to 73 over 8 minus 9 is 1/8. And lastly, we can divide by -1. We could have also multiplied both sides by -1, but it tells us p is equal to because we're saying negative p is equal to a positive number. So positive p should equal a negative. Because if one, it's really where we change the sign on one side, we have to change the sign on the other. Now the last thing we need to do is plug this in. So y is equal to 1 over 4 times p, which is negative 1/8, times x minus h. Well, our h value in this case is squared plus k, which is plus 9. Now the first thing we can do is simplify our fraction. So I would grab a calculator. 1 over 4 parentheses, negative 1 over 8 is negative 2. And the reason for this is because 4 times our negative 1/8 actually gives us negative 1/2. We can't leave it as 1 over negative 1/2. We have to reduce it, which actually reduces to negative 2. And that's it. So it is not always going to be the case that we end up with a fraction in front of the parentheses. We can end up with a whole number. And that's it. That's all we have to do for this here. So the number 2, negative 2, yeah. So all the problems we've had up to this point, the number in the location of negative 2 has been a fraction. We don't have to have it as a fraction. It can be a whole number. It can be a mixed number. Well, we don't normally write it as a mixed number. We normally write it as an improper fraction. But we get this here. Questions on this here? Questions on this so far? Now again, I've been going through this a lot slower than I have in years past, but I'm really wanting to draw your attention to the fact that every single time on every single one of these, we've been referring back to the general form. We continuously look back at that to see what do we have and how is it plugged in? How does it work? How does it connect? Because if we can keep that strong connection to that, it's going to make these a lot easier to work with. Does that make sense? Questions on this here so far? Let's look at this one here, vertex and focus. And always the first thing we're looking for is determining which equation we're going to work with. Because it's either going to be our x equals equation or y equals equation. And to find that, we're looking at the vertex and the focus. And vertex is very helpful. It tells us h comma k. Vertex is always h comma k. And again, to find the equation, well, I need to know what h is, I need to know what k is, and I need to know what p is. No matter which equation we have to find these three values. Now, when we look at the two general forms, in this here, from vertex to focus, did the x value change or did the y value change? As the x value of the vertex is negative 8. The x value of the focus is negative 31 over 4. That changed from one to the other, yes? The y value of the focus is negative 9. And the y value of the focus is still negative 9. So we know that the x value is the one that changed, yes? So in the focus, the x or the y value, which one should have the p value in it? The x, the first spot, or the second? Should be in the first, because that's the number that's changing. That's the number that is different. So when I look at this here, for our y equals, we have h comma k plus p. That put the p value in the y spot, not in the x. We need it in the x location. So if I look at the other general form, it does have the p in the X location. Do we see this here? So it tells us two things. One, our focus is H plus P comma K. Two, it tells us X is equal to 1 over 4P times Y minus K squared plus H. And again, some of this might seem like years of just math intuition, but again, all I'm doing is looking back at the general form. How do they match up? How do they align? Because if we can get that, we're just following that from here on out. And again, another way to look at this is, do they agree? Because the vertex, if we're given the vertex, it's still H comma K every single time. So for the vertex, it's telling us the value of H is -8. The value of K is -9. So if I come over to the focus, well, this is just K, yes? The vertex told us the value of K is what? -9. Does that agree with the focus that we have? Yeah, it's still saying K is -9. Because if I chose the other one, I'm going to erase this for a second. It told me that it was H comma K plus P. Is that still saying our K value is -9? No, it's saying K plus P is -9. That's not aligning. That's not matching up. And it's also saying that H, which we said was -8, is somehow the H value is turned into -31 over 4. It changed, but we didn't change the notation of the general form. Does that make sense? And yes, I will reiterate, we are taking a lot of time for very few problems that don't really need this time, but I feel that we need to give it this time. Because what is the last thing we need to find? P. So we're saying that H plus P is -31 over 4. Well, our value of H is -8. So we plug it in. -8 plus P equals -31 over 4. Now at this point here we can and this I believe should give us a positive answer. -31 over 4 plus 8 is 1/4. So the value of P in this case is 1/4. And the last thing we need to do is plug all this back in. So X is equal to 1 over 4 times 1/4. Y minus our value of K is -9 squared. Plus our H value is -8. Now again, just like I said before, if you want to adjust for the sign change with these negatives, as you plug them in, that's perfectly fine. There's nothing wrong with that. Now our Y minus -9 is going to be Y plus 9. Now we don't necessarily need the times 1. I will not count off if you do 1 times parentheses. That's fine. That is the same thing. We don't necessarily need it, but it's not wrong to include it. Because it's in English, it's the understood U, because y'all have gone over that hopefully by now. Turn the paper over. But how did you know I was referring to you? because you, especially in a sentence, if it's understood, we don't include you turn the paper over. It's the understood you in a sentence, like where you're talking to someone, you need to do this. We don't necessarily need it. It's the same with multiplications of 1. We don't have to include it if it's understood. Multiplication of 0 just removes it and it becomes 0. The addition of 0 is one of those understood. We don't have to include it. Questions on this so far? Now again, I do want to spend a third day on this. Now again, I'm doing this mainly because I really want to drive this home, but I am going to do something a little different than normal because the homework is a worksheet. It is a packet. Now, the homework is 8 problems. Now, I'm going to put it on the table over here. Now, so pick one up as you leave. Now, one thing, guys, pay attention to this here. Problems 1 through 4, we have not talked about yet because it's going to be given the equation, find the focus, direct, x-axis of symmetry, those. We're going to be covering those tomorrow. Yep. 5 through 8, if you want to start working on those, start working on those.